Good morning, good afternoon, or good evening, whenever you're watching. Hi, this is Miss Hernandez. Welcome back. We're covering October 5th assignment. This is 16.2, Solute and Solvent Combinations. My class that will be helping us with today's lecture is fifth period, my favorite class. Well, one of my favorites. Don't tell my other class. All right, so we have a topic. Well, we have our introduction to go over. As usual, I will be asking for a volunteer from my class. So,
Can I read, Miss?
thank you, Yalexia.
Dixieland music arose in New Orleans in the early 1900s. The driving style of music emphasized improvisation on the basic musical theme. Much of the sound quality associated with the music is due to the brass instruments, including the trumpet, trombone, and tuba. New Orleans is still the home of Dixieland and the French Quarter.
Echoes.
Echoes nightly through the sounds of the exciting music.
Thank you. All right. If you've ever heard of Dixieland music, it's a really upbeat type of music. It's a lot of it is improvised. Maybe it'll be a traditional song with some improvisation, meaning that they'll change it on the fly. But a real special thing about New Orleans is that wherever you go, Art District, the Bourbon Street, even at a funeral, um, they'll have music playing, and a lot of it will be on brass instruments. Okay, and that's probably why they're talking about that, because brass is a solution. It is a mixture. It is a homogeneous mixture. Okay, so if you ever have a chance, guys, has anybody ever been to New Orleans? Anybody? My students right now? I know at last period I had one student who had been to New Orleans. Has anybody been to New Orleans? Miss Garza, have you ever been?
No, but I have family over there.
You have
No,
family over there. Okay. I don't know if Miss Garza has ever been there, but I've been there multiple times, and it is a beautiful, beautiful city, known for the Mardi Gras parade, known for the unique funerals and churches and cemeteries that are out there. Um, there's a lot of really interesting and a lot of interesting things about New Orleans, but the one thing that you always hear no matter where you go is music. Okay, and it may not always be Dixieland music, but there is always some type of bands playing. Okay. Now, let's go back to the trombone, the trumpet, and the tuba. All of those are brass instruments. All of those are homogeneous mixtures made up of a combination of one or more metal, or two or more metals. Okay. Now let's see. I'm sure that's why it's coming up. Yes. Is that Dixieland music? Thank you, America, for sharing. All right. So we just heard some music. It's really upbeat, and it'll have a lot of those brass type of instruments in the band. So today's topic, one Friday, we started talking about solutions, but then the solution that we were talking about was mostly a solid dissolving in a liquid. Okay. For example, the example that was coming up over and over again was salt dissolving in water. Okay. Remember, the solute was the salt that's the substance that was being dissolved in the solvent, which is the substance that does the dissolving. That is just one type of solute solvent combination. Okay, there are 6 different types of solutions that you can have, and it's mostly based on the 3 states of matter. Okay, now we examined the primary characteristic of a solution, how water is able to dissolve solid solutes. We differentiated between a solution, a suspension, and a colloid. Remember those 3? Solutions, the particles are really, really small. Suspensions have really large particles that are trying to mix around. And the colloid will have medium-sized particles, okay? Now, solutions are homogeneous, colloids and suspensions are usually heterogeneous, okay? Usually. And you got to remember, homogeneous will have one phase. It'll look all the same throughout. Suspensions and colloids might have multiple phases, multiple parts, like oil and water, right? That's an example. That's what I want you to remember, okay? The particles of a solution are always too small to be seen and they will never settle out. A suspension, the particles are large. They usually do settle out, they'll separate, and you could usually see them with a naked eye. A colloid can sometimes be homogeneous depending. Usually the particles are medium in size. They won't settle out. They'll stay in whatever position that they're in. And it's usually an uneven distribution. So it's not uniform as far as how that solute is dissolved and spread in the mixture. There are many examples of solutions that do not involve water at all. Remember that because I think that's a question. Or that involve solutes that are not solids. The table below summarizes the possible combinations of solute solvents states along with examples of each. Okay, so all of these are solutions. You have to remember that. All of these will fall under homogeneous solutions and mixtures, okay? So let's talk about that first one. If you have a solute that's in the liquid state and a solvent that's in the gas state, it's usually going to make a gas solution, a gaseous solution. And an example would be when you have water dissolved in the air. Okay? Whatever room you're in right now, if you look around, water is floating around in there. Okay? And as you can see, it's all clear. And the amount of water is probably homogeneous, means it doesn't matter if you're in my room, if you're in Ms. Garza's room, or if you're in Alexia's or Irvin's. There should be the same amount of water in all of our rooms. Okay? If you were to if you had a gas as a solute and a gas as a solvent, an example would be oxygen dissolved in nitrogen. Okay? And again, that's the air around us. Remember we said all the air around or in our rooms is 78% nitrogen, 21% oxygen. That's the second type of solution. The third type of solution is when you have a solute in the solid form and a solvent in the liquid form. Oh, did I skip one? A solute in a solid and a solvent in a liquid. That's like salt dissolving in water, the ocean. Okay? If you have a liquid solute and a liquid solvent, it's probably going to end up liquid at the very end. And an example would be alcohol and water, alcoholic beverages, whatever they may be. So if you have a solute in the gas form and a solvent in the liquid, it'll probably stay in the liquid form. And an example would be the carbon dioxide in Coca-Cola. Okay? Carbon dioxide is dissolved in water, and then you add that Coca-Cola syrup, sugar. That is another example of a solution. If you have a solid solute and a solid solvent, you're going to make a type of brass alloy as an example, and that's a mixture between zinc and copper. Now, can you mix them when they're both in the solid form? No. You're going to have to melt them, put them in the liquid form, mix them, and then cool it, and it'll go back to a solid. And that's how brass instruments are made. You melt zinc, you melt copper, you mix them in the liquid form, you let it cool, or you shape it however you want, whatever shape you want. You let it cool, and you have this beautiful tuba afterwards. If you have a solute that's a liquid and a solvent that's a solid, okay, we're talking about this last one right here. An example would be, and it's probably going to end up being a solid at the end, mercury dissolved in silver and tin. and that is a dental amalgam. Those fillings that you have that look silver, that is a dental amalgam. And I kind of want to open my mouth and show you, but that's kind of gross. I'm sure you've seen them in your own mouth, and some of us do have them, some of us don't. If you have really good teeth, you take care of them. And I'm sure you can Google it if you wanted to, but it's just those silver fillings that you have when you have a cavity. Questions about the 6 combinations, guys? Is there any questions? We're going to see a video where they're going to talk more about this. So if you're still confused, wait to the video. He might clear things up for you. All right, so let's talk about gas-gas solutions, solid-solid solutions, and liquid-solid solutions, okay? The air, like I said, in the room I'm sitting in the room you're sitting in, and everybody else who's on this chat, you are sitting in a homogeneous mixture right now. There are many different gases that make up this solution. It's a solution that I'm in right now. Did you know that you're in a solution? We're all in a solution, okay? Approximately 78% of the air around you is nitrogen. Making it the solvent because there's more of it. And then you have oxygen is 21%, 0.9% of it's argon, 0.03 is carbon dioxide, and you have less than 0.1 of neon, methane, helium, and other gases in the solution that you're sitting in right now. On your bed, in your chair, in my chair, in your chair, everybody's chair. Okay? If you have a solid-solid solution, you'll probably have some type of alloy, bronze, brass, or sterling silver. If you remember, brass is any of those instruments that we talked about, trumpet, trombone, tuba, all of those are brass instruments. Kind of looks like an ugly kind of gold color. Bronze was mainly used for weapons in 24 BC. They were later changed to iron because probably you don't have to mix anything with iron to make weapons. Now, you don't want to have to make a mixture and then make that into a weapon when you could just use iron and make it straight into a weapon and avoid creating a mixture. Sterling silver, a lot of us have jewelry that's sterling silver. That is an alloy, okay? What metals are combined? I'm not really sure. Silver and something else, right? If you have a liquid solid solution, the most familiar example is those fillings that you have in your teeth, the silver ones. Approximately 50% is liquid mercury. The other 50%, is a mixture of silver, tin, and copper. Why is mercury used? Mercury is used because it binds really, really well with other metal alloys. Now, use of it has come under scrutiny. People are saying, why use metal? Why use metal mercury? I mean, because we all know that mercury is very toxic. So for you to have it in your mouth, in your teeth, should you be worried? I don't know. I'm worried now because I got silver fillings. I need to ask my dentist next time, are mine made of mercury? I don't know if they can take them out once they put them in. Something to ask our dentist, right? So the next time you get a filling, guys, when you go to the dentist, ask if that alloy is mercury based. And if it is, maybe we can request a different alloy. And if he says why, because mercury is toxic, tell them.
Welcome to Lecture Online, and here's a second video about solutions. Here we're going to talk about the 6 types of solutions. And you may say, wow, 6 types of solutions? Really? Yeah, that's kind of what I said when I saw that. But no, there are 6 types of solutions. The one that we're typically, of course, familiar with is when we have a solid in a liquid. So this is one of the main types. And then perhaps also when we have a liquid to a liquid. So we can imagine adding one liquid to another liquid. So we typically think about solutions when we add one liquid to another liquid or a solid to a liquid. Those are the main types of solutions that we typically deal with in chemistry. But yes, there's four others. For example, we have gas solutions. Yes, gas is considered a solution. It's a gas solution. It's not a liquid solution. And so when we mix gases together, we have a gaseous solution. A good example of that, of course, is the air that we breathe, because we have all kinds of gases mixed in with the air. Typically, of course, primarily, I should say not typically, because it would be bad if it was not, it was atypical. But primarily we have oxygen and nitrogen as the primary constituents of the air, and of course we have argon and carbon dioxide and all kinds of other gases in the air. And so you can see that's actually a mixture. You take a sample of gas here, you take a sample of gas there, and it'll have the same concentration of each of the gases, so it's homogeneously mixed. Yes, that's called a solution. We can also have a gas and a liquid. For example, we can actually dissolve gases in liquids. Carbon dioxide dissolves in liquid, oxygen dissolves in liquid. So yes, we can have those kind of solutions, those kind of mixtures of those kinds of solutions. So for example, carbon dioxide in water would be a good example of one of those solutions. Okay, next, gas and solid. Wow, so you can actually have gas dissolved in solid, and the answer is yes. Now that's not as typical, but yes, it does happen. For example, we can have hydrogen gas that's dissolved in palladium. So that's something that we don't deal with a lot in chemistry, but yes, it exists. And it is, even though it's not typical or common, it does exist, and we do have to study that somewhat. Of course, liquid and liquid, that's an obvious situation. For example, when we mix ethanol in water, that mixes, dissolves, you cannot tell the difference at all. The mixtures, they kind of combine, so it's not like you have one sample of the solution where there's mostly ethanol, another sample solution where it's mostly water. It all be mixed together homogeneously. So ethanol in water would be a good example of that kind of mixture. And of course, what is ethanol in water? That is drinkable alcohol, and of course that would be an alcoholic beverage, would be ethanol in water. How about solid and liquid? Well, that's of course one of the more common ones. That's when we dissolve solids in liquids. The most common one, of course, is salt in water. And then of course we also can dissolve sugar in water. Now sugar doesn't dissolve as readily as salt, so it may take a little bit more agitation, but eventually, yes, when we stir it around, definitely sugar will dissolve in water, just like salt will. And then we have solid and solid solutions. Wow, that's actually a hard thing to swallow when you think about solid and solid mixed together and call them a solution, because, of course, a solid is a solid. But it turns out that when we make alloys, for example, when we make steel or when we make brass, those are homogeneous mixtures. In other words, you take one piece of steel and another piece of steel that was made at the same time, it'll have the same quantities of each of the metals, each of the alloys, as we call them, that, or I should say not alloys, constituents of the alloy, that's a better way of saying it. So when we make steel, actually what we're doing is we're mixing like iron and carbon together, plus probably some other elements, but primarily iron and carbon, and that then makes steel. And we do that in big furnaces. And so typically you mix them in a liquid state, and then you let them solidify. Brass is typically a mixture of copper and tin. And again, you do that in liquid state, and then when you solidify them, of course, it's a homogeneous mixture of the two. So we call that also what we call a solution. That typically, of course, once in the solid state, it's hard to think about something like that being a solution. But nevertheless, we have to consider all the 6 types. Of course, we'll concentrate on these 2, but we'll take a look at all 6 types to get a feel of what those are and how they really work, and the chemistry of when those 2 interact and why they interact the way they do. So we'll do that in the next so many videos.
All right. Thank you, sir. So I just wanted to give you another version of the table. It's the same table that we talked about, except he approaches it differently. So I figured maybe it won't hurt to give you that extra extraversion. All right. So solutions, you got to remember they can be composed of a variety of solid, liquid, or gas materials. It's not always just liquids. It's not always just solids and liquids. It could be any combination. Okay, and they give you examples of each. Now, these are your review questions that you're gonna do. Does a solution have to have water as the solvent? I think we pretty much covered that in all the examples. Is water one of the examples in every example we talked about? I don't know. Look at the table. Is there an example of a solution where water is the solute? So, of it being the solvent doing the dissolving, is water dissolved in something else? And we did talk about an example in that table. So, that table should have at least two of the three questions or answers. Number 3, ethylene glycol is mixed with water in a car radiator to prevent freezing. So ethylene glycol is antifreeze. Okay? Right. Engines, they have to stay at a certain temperature or they can overheat and they go bad. So what we use to keep that temperature even is we have antifreeze, okay? Antifreeze just keeps the water in your radiator from evaporating if it's too hot or too cold when it's freezing. Right? It'll obviously it won't evaporate when it's hot, it won't freeze when it's cold. That's what antifreeze does. It keeps the temperature regulated of your water so that your engine always has that cooling and it doesn't overheat. So if the mixture is 40% water, 60% glycol, which substance is the solvent? Which one's the solute? Remember, the solute dissolves, the solvent does the dissolving. Okay, so I don't know if that helps you. Now, let's talk about real quick Flipgrid and your test grade that's going to come up. Now, if we go back to the assignment, I totally forgot to add the link for the Flipgrid, so I'm going to do it right now. It's because every link is different, so I didn't want to add the link and you guys have access to all the first periods. All right, so, and it's a real easy grade, guys. It's a real easy Flipgrid. This is 4th period, not that one. So I have a separate Flipgrid for you guys for 5th period. Let me get the link. Alrighty, so if you click on this link, it's going to take you exactly to the Flipgrid that's going to be considered a test for this week. It is due on Friday. Okay, it is due Friday. So make sure you get it in. It is worth a test grade. It's not a regular grade. It is worth more. Now, when you click on it, you're going to open up and it's going to show you this right here, what you see. The question is how to make a solution of Kool-Aid. You are to watch this video. This young lady in 3 minutes and about 30 seconds, she shows you how to make a solution of Kool-Aid. You're going to do your own version, okay? Excuse me. If you do not want to create a solution, use her video and just talk over it. Mute it and then tell me how to do a solution. The only catch is that you have to use 5 out of the 6 vocabulary words that I have here. You have to use mixture, homogeneous mixture, heterogeneous mixture, solute, solvent, and solution. Okay, and I put the definitions in there for you. As long as you create a video, I prefer that you make your own solution, but if you don't want to and you want to use the video here, that's fine. But I need to hear your voice. Okay? You need to use 5 out of these 6 vocabulary words. Your responses will go here. And as long as you use, and all I'm going to do is I'm going to have a checklist. Okay, did the 5 words, I'm going to write all 6. Check, check, check. Did he use them correctly? Check, check, check. You get yourself 100. This is the easiest grade that you're going to get. And this is the only test grade we're going to have. So do you have to do it? Yes, you have to do it. Is it an easy 100? Yes, it is an easy 100. Okay? But I need to hear, because all I see right now is writing. I need to hear to see how you're doing, to see if you understand what we've been talking about last week and this week. Do we understand? Okay, each period will have its own flip grid. Let me stop recording because